Greetings!
Hello,
I'm Jacob Gromlich,
and I'm James Barry.
and today we're making risotto
Why are we making risotto, Jacob?
to demonstrate gelatinization, Jim.
Gelatinization, that sounds pretty cool. Tell me more about it.
Well, that's the thickening and swelling of starch through heat and water.
Sounds pretty cool.
Yeah, let's get started.
To begin, we add oil to a hot pan. Then we add the rice and briefly toast it. Using a ladle, chicken stock is added in increments. This method is what really makes risotto different from other rice dishes. Cooking it this way allows us to agitate the rice more so than if we added all the liquid at once. Inside the grains of rice are discrete packages called starch granules that are chock full of tightly packed starch molecules. This picture, taken with a scanning electron microscope, shows how the granules tightly pack together, which is why uncooked rice is so hard. Here's a drawing of an individual rice granule undergoing the process of gelatinization. As the rice simmers, water floods into the granule, swelling it to many times its original size. The starches inside the granule begin to unpack. The frequent stirring helps some of the starch to escape out of the granule into the simmering liquid, ultimately giving the risotto its characteristic creamy texture. This picture shows gelatinized rice on the left and uncooked rice on the right. The cooked rice nearly doubled in size due to the swelling of the starch granules. Because gelatinization so radically changes the structure of the starch granule, this process is irreversible, meaning there is no way to uncook the rice. While the rice cools, Jacob will tell you more about the starches found in the rice and their role in gelatinization.
Starches are long-chain sugars made from smaller sugars that occur in nature. In grains, there are two starches, amylose and amylopectin. Amylose, as demonstrated by these Christmas lights, is a long, straight-chain sugar. It can dissolve in hot water and is responsible for the thickening of food products that have been gelatinized. Amylopectin, as shown by this branched Christmas tree, is made of the same sugars as amylose, but the links between the sugars are different, creating this branch shape. Amylopectin does not dissolve in water and is responsible for the swelling of rice granules in a gelatinized food product. In gelatinization, when the water has been heated, it will breach the outer layer of the starch granule, like in this magic grow dinosaur, and water will flood in. The amylose will leak out of the starch granule, while the amylopectin, in this case the sponge, traps the water and swells to several times its original size. When the food product cools down, the actual gel part of gelatinization occurs. The amylose that's dissolved in hot water groups up and forms weak links between one another, making the product thicken. This will increase over time until it can no longer make these bonds and looks kind of like this giant clump of Christmas lights.
This risotto looks really amazing, Jacob, and we couldn't have done it without gelatinization.
You're right, Jim, it looks tasty, and now it's time to dig in. This is Jacob Gromlich,
And Jim Barry,
signing off.